as well. Entire screen, bam. It's like this. Okay. Oh, actually, let me just mute this for an hour. Cool. Okay, do you see the presentation slide? No. Oh, you do. There might be a delay. So there we go. Okay. So as I promised, we had the fundamentals lecture, and I promised that I will explain how all of this ties into status React, because that's what this all leads to, really. So hopefully, after this presentation, devs won't be as wary of making contributions to the Nix parts and debugging them, because it's really not that difficult. So I'll go over the main entry points into Nix for building and for making shells, and how those are normally used. I'll go over the scripts, the main ones which wrap around the build process and starting shells. I'll go over the Nix packages, the ones we have customized, and the overlays to add our additional packages and our custom configs. And the hardest part of it all, which is dependencies, specifically Node.js, Clojure, and Gradle dependencies, which are all of the dependencies necessary to build the Android app. And finally, we'll go over some of the derivations that build smaller stuff like JS Bundle or Status Go, and the big stuff like the Android application. Hopefully, we'll have some time for the questions at the end. So first of all, the main entry point is default.nix at the root of the repo. That is the place that loads all of the stuff that we normally use when we start shells or build packages or whatever else. There's also shell.nix, but that's just a nicety for calling nix/shell. So let's just go here. Hopefully this one is big enough. Here we have default.nix, and essentially all it does is it imports the stuff defined in Nix, specifically in the default.nix file, because that's what's always loaded by default. And we expose 4 things, which is packages, targets, shells, and config. And we can explore this with just Nix repo, right? We can see that 4 variables are loaded. Actually, we can do it even simpler, because we can just say dot, because that just loads default. And the 4 variables are, of course, packages, some of them, targets. There's a lot of stuff there. Targets and shells, and the config, which doesn't have much in it. For example, it has some stuff like Android SDK configuration, but in general, this is everything you need if you want to build anything or play with anything in Nix configuration and status React, right? There's also shell Nix. But all it does is essentially the same thing as the default. It loads the Nix, and it just, instead of exposing things as an attribute set with multiple values, it just returns the default shell. So if I do Nix shell, I can just start the default shell by loading shell Nix, right? But the thing is, I can also specify the exact shell I want from the ones that we export. So if I want, I can use the default.nix file to access a different shell. For example, I can do Nix shell attribute. This is the same thing as that. And just do shells Android, for example. And I can specify default.nix or just dot, which actually, no, I have to specify default.nix in this case, because Nix/shell always loads shell.nix. And this should make the Nix shell, which normally you would get with make shell target equals Android, right? And it's going to build some stuff, I guess, because, of course, I refresh develop, so it's going to do that. It's silly. Now, building works essentially the same way. It loads the default.nix and specifies the exact target we care about. So in case of Status Go build, we would access targets and go for Status Go, mobile, Android. So let's do that. Okay, put here. We can do Nix build, out, link. Let's do build targets, mobile, actually Status Go, mobile, Android. And this should build a specific Status Go version, right? And this will give us the AAR file that will be used during building of the Android package. Now, you can see this in mobile app. So you can do just targets. You can see there's mobile, desktop, other status go. Here we also have mobile, and here we have Android and iOS, right? As the derivation. If I want, I can build it in the repo as well. You can just do something like this, and I would just get the resulting Nix store path. And that works because essentially through the files in the Nix directory, there's a chain of imports and call packages that get to the specific derivation that builds status go. So we can go through this chain right now and see how that works. So before we had at that point default.nix, which exposes targets, right? It comes from Nix, so we can go into the Nix directory right here. I can look at the default.nix. Default.nix imports with call package some other things like shells and targets. And target specifies other call package calls, which, for example, pull and status go, right? And then we can go into the status go directory, you can find the default, and here we can find that the returning value is also an attribute set with mobile and desktop and a shell, right? So essentially, by going through the chain of call package, we can explore the same thing as here, which is targets, status go, mobile, right? And that should give us other derivations like Android and iOS. So let's go into mobile, default, and here you have, for example, two versions of the same build with slightly different arguments, because for Android we use different architectures and different output file name, and for iOS slightly different architectures and different file name, right? And this is the resulting Android here, right? That's the derivation that we have defined here by calling the build derivation, which we'll explore a bit later, right? And all of this is essentially this kind of branching tree of call package calls or imports, which pull in everything that we build in Status React and Nix. And the central point for all of that is, for the most part, targets.nix in the Nix directory, which pulls in the status go and desktop and mobile major subdirectories. Now, shells, the way shells are defined is, of course, in the same directory as the targets, which is the shells file. The shells file also pulls in targets because they affect the shells we use, and it pulls in the default shell, the one we start with, we just call Nix shell. And that default shell is defined in just shell.nix in the shell folder. So let's take a look at that. This is essentially the shell that gets merged into all other shells. So all of the building inputs or the tools that we provide here will always be in all the other shells because we merged it with this one. So stuff like GnuMake or Clojure or Maven, it's all available. I can check it, Maven, there, because it's defined here for this specific MK shell call that creates the default shell. Also define some environment variables, so like xterm should be xterm, right? And some locales because they affect builds. But it's nothing fancy. We also specify like fixed direct home because it's used by some scripts. So status at home, right, which is the root of our repository, and also add the node module bin to path because it's just nice to have. And in shells, you can see that the attribute set of shells defines other shells, like for example Clojure one, which has Clojure, Maven, OpenJDK, node modules as well. We have a Watchman shell for the make Watchman clean target, which has just Watchman, in addition to the things that it gets from the default shell, and so on. Like more advanced shells, like the Gradle shell, which pulls in Gradle Maven, and the resolver, which we use for dependencies, and sets some environment variables. So, for example, we have the SDK available. And all of those shells are returned here, and they are merged with the default shell. The construction here isn't anything special. It's essentially a map over the list of over the set of shells, and we call on that map the function that equals merge shell with default shell. Merge shell is something I've made. It's nothing special. It just essentially combines build inputs and shell hooks into one thing. Now, all of this is made available specifically in the makefile through wrapper scripts, which are all collected in Nix/scripts. And the main ones we are interested in are source, build, and shell. There's other ones like setup, which installs Nix, and purge, which removes everything Nix related. But the main ones that developers use every day are build, shell, and source. Right? Now, source is actually very simple. It essentially just makes sure that we have Nix tools in the environment available. So for a Nix installation on an existing Linux distribution, it would source the Nix profile, .nix profile from your home. On a Nix OS, like for me, it wouldn't have to source a profile. So let's look at that. In the script directory, we have source.sh. And essentially just checks if Nix is available. If it is, just end it. If not, load the profile. If there's no profile, install Nix, load it again just in case, because after installing we need to. And if Nix is still not available, then we fucked up and we need to stop. Very simple. And pretty much every script in the scripts directory uses that in order to make sure that it has Nix tools in the Nix environment available for it. Now, the next one is, of course, shell.sh. And that is simply a wrapper around the Nix-shell that you saw me use before. The main thing it does is just adds extra arguments for Nix-shell in order to make it more sane and predictable. So, for example, if you go into shell, you can see that it handles the target argument, which defines the attribute, also known as this, for the shell, right? And also define some other environment variables that it accepts, like status go SRC override or Nimbus override, build type, and some other ones. Actually, I could probably remove this. And at the end, it essentially just calls Nix shell in two variants, either with run, where it runs a specific command, or with no run, which means it opens an interactive shell. Why this matters is because if we look into the makefile, and we'll look at the shell target, which people probably know, and they call make shell target equals Android, for example. What happens is it calls shell Nix with this special variable at the Nix shell, which causes it to just call it without run, which makes it an interactive shell. And in case of a command, like for example here, this will be called with run. So essentially, Nix script shell sh is the substitute for bash in the makefile, because specifically of this, right? Now, the other one is build.sh. Actually, before let me just show you real quickly. Let's do Nix scripts shell.sh, right? Now I need to check that. Whatever. Build.sh is also a wraparound Nix/build the same shell is, and it also adds a set of flags. So I'm going to do that. It does some nice stuff like clean up after builds if you want it, but the main thing is it specifies just some additional flags and calls Nix build and returns the value. So, for example, the same way we do Nix build, out. I think, for example, targets, status go, mobile, Android, right? What? In the rogue folder. Oh, I forgot -A, of course. It would give me the status go build. I could do the same thing by just calling Nix scripts build.sh without the flag, because it just takes one argument. And this would, as you can see, just run specifically Nix build with some additional flags. and the result will be the same. The main thing is it's a wrapper that also copies stuff into a result, just for easier usage. Cool. Now the next big part of Nix are packages, because all of the tools that you've seen that we provide in the shells, like Gradle or Maven, come from somewhere, and they come from Nix packages. Normally, you would use Nix packages, which is the repository in Nix GitHub org, that you would just fetch by default when you import it with something like, let me show you, something like here, you would replace this with Nix packages, because this is a special format that just uses the default Nix packages you would get without any configuration. But because our environment is kind of special and we have to apply some patches to Nix packages, we have our own fork in status.im org, which we fetch and provide to the Nix scripts. So if we go into, for example, default is, I guess, fine. When we get packages, as a default, we provide packages.nix from the Nix directory. So let's take a look at that. And all this file does is essentially takes the config from the argument. It fetches from GitHub our own fork of Nix packages, and we get fetched from GitHub from normal packages, as you can see. And then we just provide it at the end with import, but we call it with some additional arguments, specifically config and overlays, right? Now, this makes it possible so that if you do Nix repo, I can do, for example, pkgs Gradle, right? And that should be a derivation for Gradle, right? And the reason we customize it with config and overlays is because packages are passed around with call package throughout all of our Nix expressions. So this makes it easier to access certain things. So the config that we provide is mostly our own config with two exceptions. There's some Android SDK configuration, and actually the other configuration is also Android related. So if we look at the default config we load, that we provide and merge with the config provided in the arguments, if we go to config, we can see that there's a whole section with status-specific configuration, like build type or build number, or Android-specific configuration, like architectures that we build for. And also some generic Nix packages configurations, like, for example, accepting of Android SDK license, without which it wouldn't build. And also using old open SSL, because that's what Android SDK uses, which is, well, what can you do? And this is applied in the packages.nix through the arguments that we pass to import our own packages. Because if you look at where we get fetched from GitHub, the import of normal standard Nix packages is called with empty arguments, right? Because if we excluded this, the import would just be a function. So we need to pass empty arguments. And in this case, they're not empty. We specify our own config, our own overlays. Now, what are overlays? Overlays are a way to customize packages by replacing some or adding new ones in the packages namespace. And we do this in the /nix/overlay.nix. So as you can see, we import packages overlay from overlay.nix, and we apply it here for a list of overlays. So let's take a look at our overlays. It's actually just a big file, which is a function, which takes two arguments, self, which is the old version of packages, and super, which is the new modified by us version of packages. It's kind of recursive, but it mostly works. And we specify, for example, overrides for packages. So we specify the exact version of Node.js, for example, because we want only 12. Or we specify the version of OpenJDK, because we want the specific version of OpenJDK. We also provide additional packages that we define ourselves, like Go Mobile, which isn't normally available in Nix packages, some Qt stuff, or Go Maven Resolver, which we recently added. So let's take a look at one of those packages, right? And that would be one of the simpler ones would be Go Maven Resolver, because building Go packages is pretty simple in Nix. So as you can see, call package takes them from pkgs, Go Maven resolver. So let's go up, pkgs, Go Maven resolver, default. So yeah, we build the package with a special derivation, which is kind of like an MK derivation, but just extended, which is called build Go package. As normally for a derivation, we specify program name, version, and some additional stuff like the revision. And we fetch the sources from GitHub with the same function as with Nix Packages, with the specified repo, revision, and SHA. And also add some dependencies because they have to be specified, like cryptonet sys from Golang. And because we specify it here, and we provide it through the overlay as Go Maven resolver, what we can do in Nix repo, we can do pkgs, Go Maven resolver. There it is. We can build it too. So we can just do comma build, and that's the resolver. So actually, we can do the same thing with just Nix build. No out a, and let's take this name. We have the path. Let's look inside. There's a bin directory, and inside of the bin directory, there should be the binary itself. So if I call it with help, there's the binary for the Go Maven resolver. So essentially, the overlay is just a way to add more stuff to the normal packages, right? Because I could do the same thing for example, Gradle, right? I would get the Gradle binary. Gradle, right? Here we go. It's just a way to extend what normally would be available when you call packages with call package, and pass around all of these tools which would be used in different kinds of builds. Cool. Now, in addition to packages, we also have dependencies, which are slightly different. And this is the most complex part of how Status React uses Nix, because we have to define by ourselves the exact dependencies we need. And this is all also defined in the overlay, specifically under the key deps. And you can see this here. So we pull in the different dependencies for Node.js, for Gradle, and so on into the deps key. So we can find that with Nix repo. And you would have pkgs deps, for example, and Node.js ones or other ones. So let's start with the simplest one, which would be Node.js. This uses a utility called yarn to Nix, which essentially just takes the yarn log and package JSON, and is called with those arguments plus the name, and creates a derivation that contains all of the packages that normally yarn would install with package.json provided, right? We can take a look at that. So we have Node.js deps from deps.js, let's go, JS default. And yeah, we have loading of the yarn log, the package JSON, some other stuff for the name, and we just inherit all the stuff and call mk-yarn modules to make those node modules. So let's build that. Let's do Nix build out pkgs deps node.js. This should give us this. Look inside. Yes, we have the node modules in there. And we can add the node modules themselves. And here we have what you would normally see if you just run the yarn install, right? Now, this alone isn't enough because our packages are kind of special, specifically because we use React Native packages, which, well, are native. So they, for example, include things like Gradle.build. And Gradle.build has references to external repositories like Google or JCenter or Maven Center. And those references would break during build time because Gradle will try to fetch from external repositories at least POM files to figure out what is the dependency tree. So we have to stop it from doing that. And in order to do that, we have to patch the already built Node.js modules. So next to Node.js, we have patched Node.js modules. And what happens there, essentially, is we take the existing dependencies that we have. We have three phases. We have unpack, patch, and install. The unpack phase does just the simplest thing, which is it iterates through the deps.js that we saw here, right, in the subfolder of node modules, and it symlinks every module in the node modules into our build directory, and also copies.bin, because we don't want to symlink that, we want to copy it, so the relative symlinks are retained as they are. Then we have the patch phase, which, in simplest terms, essentially just goes through the node modules, finds build Gradle files, unlinks the module and copies it, because we cannot modify a build Gradle in a module that is symlinked in the store, because the store is read-only. We make it writable, and then we patch the sources for the specific build Gradle module to use Maven local rather than entries like Google or JCenter. And we can see this work, because before we had Node.js, and if we take a look, for example, at a specific dependency like node modules, React Native, FS, Android, build Gradle. What? Wait, type something poorly. Android build Gradle. Oh, cat. We can see that the repository is JCenter, which is an external repository. So instead of building the Nix, the Node.js one, we should build Node.js patched, which is a different derivation that symlinks most of the modules. And we can take a look inside node modules. We can see most of them are symlinked, right? But some of them wouldn't be, like specifically React Native ones. So let's take a look at the React Native one. That would be this. Let's look inside. Oh, right. And we've replaced it with Maven local, because that's what this does. That's a separate script. It's nothing fancy, it's just running sed. So we've made a patched version that essentially symlinks everything it can, and when it cannot symlink, it copies and modifies the build Gradle. We also do some other patching like shebangs in scripts, and some specific patching for React Native, like no build ID for reproducible builds, and some other stuff in React Native, but there's nothing fancy about it. Oh, and we run Bitify because we want to update old modules to Android X namespace. And then we just put stuff out into the out directory, right? And that's why we get the node modules here, as we saw. That's pretty simple. There's nothing fancy about it. Now, the next more complex example of how we manage dependencies would be Clojure. The problem with Clojure is that we need to extract the list of dependencies somehow, and this was done with help from Eric. We can do this with the Yarn Shadow.cl.js class path, right? So if we look into Clojure, and then there's a generate script that essentially what it does is it calls Yarn Shadow.cl.js class path, and it generates a list of dependencies for that class path. Right, so we can do this. We can do like Nix shell shells Clojure. What did I break? Oh, default. There we go. And we can try the same thing that the generate script runs. So let's take Yarn Shadow.cl.js class path, and it should give us this huge class path that has all of the jars that Shadow.cl.js would expect in order to build this, right? Actually, let's do it with tr so it's easier to read. Yeah, so we have this list, which essentially turned into this without with the relative path, or no path at all, actually. And then what we just do is we iterate through those, and we generate JSON entries for those dependencies with the shards for the font and the repository that the jar will be available in. So if we look into the JSON for each dependency, or I guess 6, yeah, CLJS bean, it should be somewhere here. CLJS bean, yeah, there it is. It comes from Clojure's repo. That's the pom shards and the jar shards, right? And we take this this pretty big file, and we use it in a derivation that essentially just iterates over the contents of the file And for each dependency, it downloads and symlinks the POM, the jar, and puts the shards in place. And that's all it does. So we can, for example, do nix build out packages deps closure. I should give us a dependency tree, which would be the same as we would find in your home.m2 repositories that Maven would create, right? So we can take, for example, do find. Yeah, you can see there's shards, there's jars, there's POMs, everything you might need to build the thing we build with Shadow CLJS, which is the JS bundle. Oh, and the jar and the POM is, as you can see, symlinked, safe space into the specific derivation that just downloaded it, because it's a separate entry in the store, right? Now this isn't that bad. What's really bad is Gradle, and this is the thing that annoyed a lot of developers and took a while to fix. The Gradle dependencies are much trickier to manage, and what we do is essentially we also have a generate.sh script, which also has to find dependencies like the way we do with Clojure, with the class path. But what we do is we do 4 steps. We call Gradle projects in order to get the list of all of the sub-projects, like React Native projects, plus ours. Then we call Gradle again with those projects and some additional arguments in order to get their dependency trees, and we parse that with AWK for a nicer output. And then we push that output through Go Maven Resolver, which for all of those dependencies finds the URLs of all of their POM files and all of their own dependencies and returns the list of those URLs. And finally, we take those URLs and we generate the JSON that is consumable by Nix. So let's take a look at the generate.sh in Gradle folder. It calls get projects, right, and generates the project list, which looks like this, which is just our app and the React Native stuff. It calls get deps on those projects in order to generate the list of dependencies, which is here, deps list. There's a bunch of stuff, like 500 lines, yeah, with multiple versions, because that's how Gradle works. And then we take the list of those dependencies and we push it through Go Maven Resolver in order to get a list of URLs, which we put into deps URLs. And this is the same thing except with specific repository URLs, so we can download the POM, right? And finally, we take all of those URLs and we pass it through URL to JSON with parallel, because that's faster. And we generate this, .json, which is essentially the same as the Clojure one, with one difference. We also have type, because Gradle dependencies can be jars or AARs, because we're building for Android, or just POM files. Some dependencies are only POM files which specify other dependencies. And all of this is consumed in the default Nix derivation, which looks essentially the same. We load the JSON from the .json, and for all of those dependencies, we iterate and we symlink the POMs, we symlink the jars, we put in the chats, and we get the resulting derivation. There's also a patch phase in addition to the build phase that creates those. We also have a patch phase, which does a patch for AAPT2, which is an APK builder that Gradle uses, which has a small issue with the library. So we patch that. And we can do the same thing. We can do nix build out pkgs deps Gradle. And we should get all the dependencies. So we can go into, for example, JUnit. Yeah, go inside. And we have the jar and the POM and the shards. Simple. That's yet another dependency available in the packages through the overlay. Now, the derivations that combine all of that into an actual package that results in, for example, an APK are a bit more complex. And they usually sit at the top of the subfolders like status Go and mobile Android or mobile iOS. So let's take a look at the simplest one of them first, which would be the JS bundle one. And the JS bundle one essentially just what it does is it takes the Node.js dependencies, Clojure dependencies, and the sources from the repository root and compiles them with Java using shadowcl.js. So let's take a look at the derivation. Let's build it real quick. So we have targets, mobile, Android, JS bundle, right? Motherfucker, it's building. Oh, let's give it some time. And let's take a look at targets. Mobile is in mobile. And then we have Android in the Android folder. And then we have JS bundle here. And JS bundle, essentially what it does is it's a derivation with its name, with a source, which comes from our repository root, relatively, and filters the root of repository by specifying regexes that to limit the size of the files we pull in, right? So we want some CLJS configuration, some Git files because CLJS checks something, JS files because it runs npm for some reason. Resources translations, but we don't want fonts, so we skip them. And then essentially what we do is we run unpack phase, patch phase, configure, and build. So we patch because we patch the shadowcl.js EDN file because we want to make it use a local repo. And as local repo, we specify the depth closure, which we just talked about. There's a directory in Nix that has the closure dependencies. Then in configure phase, we symlink node modules from depth node.js. Notice these are not patched ones, because normally it would be patched, right? But we're using the patched ones because we actually don't need them to be patched in here, so it's faster. And we copy JS files because, well, it runs on npm, so otherwise it would fail. And finally, in the build phase, we provide the class path for Java with the closure depths combined with columns. And we call Java with JS module to build closure main for release mobile. And we put it into out. So if we look at the output, there's our index.js, right? And actually the actual file is in the app folder in index.js. Yeah, that's properly big. So that's pretty simple. We can see how the dependencies are pulled in, right? We specify the closure dependencies twice because we specify them by modifying shadowcl.js, and we specify them as class path. And we specify Node.js as just symlinking node modules into the root of the build directory, right? Nothing special. Now, another derivation we use, which is status go one, which is slightly more complex because of the number of platforms we build for. But it's not that complicated, really. Let's build it real quick. So that'll be status go mobile Android, right? And that should give us the AR. Now, this is built. Let's see. Define targets. We have status go directory, folded by call package. Going to status go. We have the default file. The default file provides some common stuff like metadata about the package and license, some common flags, the source, some additional flags for params and build flags. And then we pass those to, for example, mobile specific build and desktop specific build by inheriting them. So let's go into mobile, default. And in default, we have two configurations, one for iOS and one for Android. They're different because, well, they use different architectures and the output files are different. And of course, the platform is different, right? So if we, for example, try to build for iOS, this would fail because we have no Xcode, right? But the Android one works. And Android one works by calling the build with call package, which is here. And that's standard. We use build go package, which is, as we've seen before, a fancy version of MK derivation. Specify the name, version, so build tools like OpenJDK, Xcode for Darwin. We prepare in the pre-build phase some environment variables like return of Go modules. We add Go mobile to Go path. We provide Android modules if we're building for platform Android, right? And finally, we have the build phase, which essentially all it does is it just calls Go mobile bind with the targets and the flags that we've provided, right? And we get the resulting output file. which finally, in the end, we also have a fixed update for references to Nix. And finally, we put them into the route, which is how it ends up in this folder. Right? And the thing is, you can pretty easily modify the way we build this, right? So let's say we wanted to build the same Android status Go build, but only for 386, right? What we could do with Nix rep, for example, is we could get the derivation, which would be targets status Go mobile Android, right? What we could do is we could do override. This is an argument we don't care about. And we could do actually we copied architectures equals 386. And now this should give me a modified derivation. So let's save it as O with derivation, and now let's build it. O. I can see again. Go. Terminal is too small. Yeah, there we go. It's building for 386 only, because we overrode the arguments with architectures only for 386. Simple. There's also other ways to override packages, but essentially any package you find, you can create an override by modifying the argument it was called with, or even modifying the specific build go package arguments. So, for example, we could change the program name if we wanted to. Now, the biggest derivation we have is the Android one, because it combines all of the things we've seen so far. It combines the closure, the Gradle, the Node.js dependencies, it combines JS bundle, status Go, and all the sources in the repository in order to build the APK, right? So, first of all, let's take a look at the derivation itself, which is in Nix mobile Android release. Go there, mobile Android release. Right. So we have, of course, like normally, we have NP derivation with a name. We have a source, which is coming from the repo root, but we're using, as before, a filter to specify exactly which files we want for the build, because we don't want everything, and reduce the size and the time. We're pulling JS files, transaction resources, an Android folder, which is probably the main source of modules for this build. Specify some build inputs like OpenBDK, Gradle, right? For Darwin, I guess we use Patch Watchman. Oh, and of course, there's no make in Darwin by default. We get some settings, and we see quite a few phases. So we have the unpack phase, which gets the sources. We have the post unpack phase, which, for example, copies the env file, copies the JS files, copies the JS bundle we've built, that we've shown before, adjusts permissions, copies the patched node module folder into the build directory, and makes it writable because Gradle modifies files in them. And also patch the same way we patched build Gradle files in node modules with the same script. We patch our own one in the repo root. We'll also make sure we have, if we have secrets, we load them. And they're loaded from a file on the file system because we don't want them to be part of the derivation because they are secret. We copy the key store into the build path. We verify that we have the environment variables necessary to actually sign the APK with the key store, certificate in the key store. And finally, we have the build phase, which essentially just runs Gradle with arguments we specify specifically, and most importantly, we provide Maven local repo as deps Gradle. So we use our own Gradle dependencies, version code, and we specify the target to assemble, which would be like PR or release. I also have a small check phase to check that the bundle, once unzipped, actually has an index Android bundle, like a very simple sanity check. And finally, put out the APK. So when we run Nix build, it's probably going to fail because, well, it's going to take a while. No outlink. Targets, mobile, Android release. Will it work? Huh? Huh? Takes a while to collect all of the inputs. Yeah, it's gonna want to build it because something changed the repository. Well, whatever. But the point is, it will result in the APK in the output in the Nix store, right? It's quite a bunch of phases, and we could probably split it a bit, but the phases aren't really that complex by themselves. The main thing is that we need to provide all of the dependencies in the right way. The base bundle, the patched modules, the Gradle modules through local repo, and the key stores, right? There's also a way to build with a default key store, which we provide for arguments. So for example, if the key store isn't provided by config, we just use our own, which we create like ad hoc to use it if there's no specific key store, because we use the config to provide the key store mostly in CI when we have an actual key store with actual certificates necessary for release builds. Now, this is pretty complex and it has a lot of arguments, which is why we also have a scripts release-android.sh script, which handles all of the additional arguments, right? Because as we've seen in, for example, config.nix, we have a bunch of status-specific config values, like build type or the Android stuff, right? And those things are used in the Android release build. So you can see that we are loading the build type, the Gradle options, the key store path, which doesn't have to be specified. And if it's not, we use our default key store, and so on. So in order to simplify this, we have scripts release Android. There we go. Which all it does is actually gets a bunch of environment variables like let's go override or build type or build number, and provides them as arguments in the config, right? So we have the status.im key. I'll be sure that we can go back to next config. So we have the status.im Android API split. There it is in Android and status.im, right? So if I want to, for example, build with a different build number, I could do something like config, let's single quote this, status.im build number equals 10. And that would provide the build with the specific build number, which would be loaded in the release build number right here. Right. Okay, let's stop it. Okay. Now, iOS doesn't have a derivation right now. It probably should, but we never got around to it. What it has is just a shell that specifies all of the necessary tools, like bundler or Xcode wrapper. And we can find this in the mobile iOS directory, along with some other tools. So, for example, if we go to mobile iOS default, we have the normal MK shell with some build inputs like Xcode wrapper, and some additional shells like Fastlane, which has its own shell with its own environment variables, status go, pod, and we call node modules to get our patched node modules into the repo. So essentially, this is a shell that we pre-prepare for calling Xcode build. And we could run it with for a derivation and just never go around to it. So you would just make a derivation that essentially takes the same inputs as here, and we will do the same things, except this, because we don't need this. It will probably just copy this, rather than calling node modules.sh, and just call Xcode build. So I'll have to get to that eventually. Cool. So some of this is explained in Nix Markdown files in README known issues and details. I'm slowly expanding that. Hopefully, I can add more to that after this. And we also have the previous presentation, but I did this presentation mostly to just expand the knowledge base and make it easier to start working with Nix and get an entry point to how it works. There's also something that's coming in Nix. There's an RFC number 49, which is called Flakes. And it's essentially a standardized way to define how projects like ours have all the targets collected in one place for easy access, easy building, and easy management of configs. What you saw was me essentially making the stuff up and standardizing how we manage config and where we put targets to build and where we put dependencies. But Flakes is a way to essentially do the same thing, but in a standardized way for Nix. So hopefully once that out, I'll be able to make this even simpler and even clearer, right? Cool. I think that's it. If you have any questions, now would be the time. If there's no questions, then I guess we can finish. I'll just stop the presentation and have a lovely day, I guess. Stopped.